Hey everybody, happy Sunday. I said that I was going to make a video for you to help you guys with the math. The one I'm going to practice with is from the sample free response packet I gave you, the 2010 one. And looking at question 2, we did question 1 together. Remember in class we split 3 and 4. So let's do probably the more difficult one, number 2. I remember when the seniors took this, they really hated this question, so I want to break it down for you, make it as simple as possible. So let me read through this. It says, termites are social insects that are essential decomposers in tropical rainforest ecosystems. Termites may account for up to 95% of insect biomass in tropical rainforests. So that means, by biomass or, sort of like by weight standards, 95% of the insects are termites. Termites consume vast amounts of dead and decomposing plant material thanks to the work of mutualistic, cellulose-digesting microorganisms that inhabit their guts. In addition to their roles as important decomposers, termites digest plant materials and directly contribute to carbon dioxide and methane emissions into the atmosphere. It is likely that many insect species, termites and their symbionts may be sensitive to changes in the microclimate caused by global climate change, especially with regard to temperature and humidity. So there's a little table, and it says letter A says, respond to the following using the data in the table above, which gives the rate of wood consumption by termites in milligrams per day per termite under various temperature and relative humidity conditions. Under optimal conditions, the emission rate of methane by termites is approximately 70 kilograms of methane, CH4 is methane, per year per 1,000 termites. So every 1,000 termites every year, about 70 kilograms of methane goes into the air. And you know that methane is a greenhouse gas. 1. According to the data, what are the optimal temperature and relative humidity for termite activity? So here's my graph, and they just want you to read it. This one says, again, it says the rate of wood consumption. So I want the optimal temperature and humidity for wood consumption. So if this is a number that tells me the rate of wood consumption, and I want the optimal, that means I want the highest number. And if I look across the different rows and different columns, the highest number is right here, 0.27. So that tells me the optimal conditions, and this is how I want you to write it. I know Natalie asked this question earlier. You basically, if I was writing an essay, I'd do one parentheses like this, and I'd say the optimal, and I don't want to write this all out, but the optimal temperature and relative humidity are 30 degrees Celsius and 90% humidity. So basically what I'm saying is that if the temperature is 30 and the humidity is 90, the termites will munch the most wood. Now let's get to some math. It says, given a density of 4.5 times 10 to the 7 termites per hectare, hopefully you guys remember what hectares are. It's just another name for an acre. So there's 4.5 times 10 to the 7 termites per acre, and optimal conditions. Calculate the annual amount of methane emitted in kilograms by termites inhabiting a 2,000 hectare tropical rainforest. Alright, so how do we do this? Here's a math question. And I was telling, I forgot who I was talking to, but even if you mess up the math section, it's only a one question out of the free response, so you'll be fine. I feel like a lot of you are intimidated, which is normal, but I think at least you could put enough down where you get partial credit. First of all, it says it's 2,000 hectare tropical rainforest. So we're essentially, they're giving us 2,000 hectares, and they want kilograms, determine the amount of methane in kilograms that would be emitted by the termites. Okay, so given a 2,000, sorry, I'm ahead of myself. Number 2, it says calculate the annual amount, of methane emitted in kilograms. That's what I want. I want the annual amount of emitted kilograms. So the units that I want is how many kilograms of CH4 per year. That's what I want. How many kilograms of CH4 per year, right? You guys understand that? So let me just move this or delete this real quick. So I want to know what is, I don't know why this won't delete. Oh, well, there you go. I want to know if I have a 2,000 hectare rainforest, how much kilograms of methane per year am I going to get? So I told you always to start with what they give you. They give me 2,000 hectare tropical rainforest. So maybe I could write this here. We got 2,000 hectares. Okay. And then I need to find something that would cancel this out. So remember in this one it says I have 4.5 times 10 to the 7 termites per hectare. So I'll multiply by, and just to get this to cancel out, for each hectare, I have 4.5 times 10 to the third, 4.5 times 10 to the 7 termites. I know this is messy, so just bear with me. And then I need to get rid of termites. Remember, ultimately, I want CH4 per year. Okay. Now, it's not in this question, but over up here it says I have 70 kilograms of CH4 per year per 1,000 termites. Right? So it tells me to cancel out termites. Okay. For 1,000 termites, remember it says for 1,000 termites. For 1,000 termites, I get 70 kilograms of CH4 per year. Which is actually, if you remember, that's the unit that we want. So if I do this correctly, and I'll use a different color, blue, hectares cancels out with hectares down here. Termites up here cancel with termites down here. So now to get the answer, all I got to do is multiply across and divide by 1,000. Here's the problem. You don't have a calculator. So you're going to have to convert these all into scientific notation. This is 2 times 10 to the 3. This is 4.5 times 10, and I'm multiplying across. 4.5 times 10 to the 7. Sorry, I know it's really messy. 4.5 times 10 to the 7. And then I have 70, which is 7 times 10 to the 2. Yeah? So what I'll do, if you guys remember how to do multiplication, what I do is I... Wait, 7 times 10 to the... 7 times 10 to the 1, sorry. 7 times 10 to the 1. So if you guys remember how to do scientific notation, what I will do is I'll multiply all of these numbers. Okay. And also, if you're really stuck, I could just leave it like this, or I could just like multiply and then divide by 1,000. Like I could also do that as well. Okay. So what I'll do, if they're all like this, gosh, what am I going to do? I'm going to... So what you're going to do, and for lack of time, I'm going to literally multiply. You're going to have longhand multiplication. 2 times 9.5 times 7. So you're going to have to longhand multiply that. I think this is 19. 19 times 7. 3, 6, 133. Then I add all the exponents of this. So like 3 plus 7 plus 1. I add those up. I get 11. So it's 133 times 10 to the 11. Okay, you can move this stuff around, blah, blah. But remember, I'm also dividing by 1,000. So I'm dividing by 1 times 10 to the 3. Same thing, I divide the main number. So 133 divided by 1 is still 133. And then I subtract the 2. So it's going to be 133 times 10 to the 8. Hopefully that makes sense. I mean, I can't ask you guys any questions, but that's how you'd multiply it. And then also never forget to do units. Okay. 3 says, suppose the temperature increases 35 degrees and humidity decreases to 50. Using the data provided, determine the methane that will be emitted by termites in a 2,000 hectare rainforest. So remember we did optimal conditions, so this was our answer, right? This 133. And that was optimal conditions, it's 0.27. But it says we're going to increase to 35 degrees Celsius and decrease to 50. So 35 and 50 is 0.09. It was initially 0.27, but now it's dropping to 0.09. So all you're going to do, I know it's hard because it's the math part, but you take your answer in 1. Remember, this is optimal conditions. And I'll multiply that. Let me see if I can delete everything. Oh, now it wants to delete. So let's just say, remember our answer was 133 times 10 to the 8. Let's just say that. And that was optimal conditions, right? But now I've dropped to 35 and 50. So now I'm actually only getting 0.09 instead of 0.27, which was optimal conditions. So all I do is take my answer in 1 and multiply by that ratio of 0.09 over 0.27. Because now I'm only getting a fraction of what the actual optimal conditions are. Okay. And again, you don't have a calculator. I could box it like this. I could round this to 0.1 and 0.3 and try to figure it out as well. Just know, as long as you write the work down, you'll get partial credit. And the last one is to explain why the population size of termites is also affected by temperature and humidity. It's a very simple question. All you could say is that that is the limiting factors. You could also say under the right temperature and humidity, they can't eat as much wood. Maybe you could say they can't reproduce. You just need to say, like, why would population size be affected by temperature and humidity? Just say if it's not optimal, then they can't function. B, it says, is observed that soon after a rainforest is cleared, termite density increases to 6.8 times 10 to the 7. So initially it was 4.5 times 10 to the 7, and now when I clear the rainforest, now there's 6.8 times 10 to the 7. So a significant difference of termites now. Thereafter, the termite population decreases dramatically. What is the most likely reason that the density of termite increases when a tropical rainforest is cleared? It's very simple. If you clear a rainforest, now you have all these trees on the floor. You basically have an abundance of food. So now all these termites are going to go crazy because now all this extra food is on the floor because we just cleared it. Okay. Why do the termite populations eventually decrease dramatically? So you might talk about a boom and bust cycle, or you might also talk about carrying capacity. If a rainforest is cleared, eventually all that wood is gone, and once that wood is gone, the animals, in this case the termites, are going to decrease. It's almost like all of a sudden have this extra surplus of food, and now when it's all gone, that's why the population decreased. So the temperature will boom to 6.8, and then it's going to bust because it's way past its carrying capacity. And then letter C, last question, says describe one way, other than changes in termite activity, that tropical rainforest destruction contributes to anthropogenic climate change. You may have forgotten what anthropogenic means. That means man-made. So it says describe one way in which we have, if we destroy the rainforest, we have more global warming. Okay. They use climate change because remember the globe warms one places and gets colder in other places. There's a lot of answers you can write here. Remember that the tropical rainforest is responsible for photosynthesis. So it takes in carbon dioxide. If we destroy the rainforest, now that carbon dioxide cannot be taken in by the trees and then goes up into the air. So that's one. You could also say like burning the trees or cutting down the trees in itself increases the amount of greenhouse gases you use. But long story short, the correct answer, not the correct answer, but the most common answer and the best answer you can write is that by chopping down trees, just like in the Lorax, if you lose the things that take in carbon dioxide, which is a greenhouse gas. So hopefully that is helpful for you. I know you guys are very anxious and nervous about the math. If it's the only question you're getting it wrong, you're still going to get a 5. I feel very confident you guys will be okay. Tomorrow morning, I know some people can't be here at 7, so at the very least, at 7:30, we could have some food, and we can go over very quickly some practice math questions, so hopefully you guys can make it. Other than that, I'll see you guys tomorrow. Sleep well, and good luck.